bring all these two items together, actually it's 3 items, right? We have 3 members here, right? We can do model check. We can put the filter on this model. We can do some, as I said, precautionary, we can go through the precautionary warning items when we build the model. How? Let's now move to the next slide and start from model building. Okay. Let's go back to reliability report and quickly describe the systems that supports our reliability system, right? Subsystems, actually. What we are doing first, we have data collection system, data processing system, data reporting system. Now, answering questions, right? How building models? Because we need to understand, right? This is the very important part. Again, I'm talking here from general, high-level perspective. Each case is individual. Each case is unique. But as I said, we're gonna see some general filters here. When actually, what is the first step building model? Let's start from first step. When we are taking this collected data and put in our database. What about next step? Let's say we have, now before we had the previous presentation, we need to calculate interval, right? Now let's say we have to calculate the first 3 months BPCU removals. January, suppose January we had, again, example, right? January we had 2 removals, February 2 removals, March 3, and answer is first 3 months removals, answer is 7. So we don't have any questions, right? 2 plus 2 plus 3 is 7. This is from our theoretical model side, right? Our function, distribution, mathematical statistical analysis side. But what about from reliability engineering side? What about from real life side? From reliability engineering, we need to understand what is behind these 2, 2, 3. Let's say first removal, because we are talking here BPCU removals, right? We had first event was January 1st, 1 removal. Second was January 30. In February, we had February 14, 1 removal. Second, February 28. In March, we had first 2 removals. March 15, just example. It was same day, same aircraft, and then I hope you understand where I'm going here, right? Not repeating. We already had this discussion in previous chapters when we discussed reliability and back 5, 6 presentations. So we have same day, same aircraft removals. March 15, and then last third removal happened, let's say again, March 25. Now, we can ask questions, so what? 1 plus 1 plus here, right? Here also plus. Answer is also 7. Yes. Answer is 7, but as we can see, even from mathematical perspective, even combination of numbers are different. As you can see, the second model, low-level model, right? It describes actually removals day by day. And then in this case, when we said same day, same aircraft. So we can, as we said, in previous chapters, right, we can go down the positions, etc., etc. Now this is, let's say, from removal perspective, right? Real life perspective. We can say, okay, this is some practical side. What about from modeling side? The same story. Suppose this is not the removal per removal, this is removal per 1,000 flight hours. And we have to go again, 1 level down, to understand what's actually happening. Let's say, let's take this one. This one is 0.3 removals per 1,000 flight hours, as we said, plus 0.7, or it is 0.34 plus 0.74. So 0.4 is 0.8, and answer is here 0.1 is 70. And I'm not talking here now about safety and reliability. It's not even arguable right here. But if we have, let's say, 100 aircraft, this 0.1 can cost us, talking here now about the better understanding for learning and training purposes. By the way, all these examples here we have for learning and training purposes. So this 0.1 can cost us hundreds of thousands euros or dollars, whatever you like. So we have to be very careful. Next level is definitely go, okay, 1,000 flight hours. Okay, what is the real life removal? Like here. So how we can solve this type of problem, right? What we need to do from modeling perspective. Not to solve, but at least as we said, solve is not correct. We cannot solve it. Chance is almost 0.0001, right? But how we can minimize, this is the proper word here, our mistakes, our errors, and how we can bring all these distributions, functions, theorems, equations, models close to the real life. This is the task. And then from general perspective, not from task-specific perspective, as we mentioned, right? Not from distribution, function-specific theorem, equation, formulas perspective. Today we are talking here about from general, high-level side, right? As we said, we can put some filter, or we can do model check. What we have to check? We have to check model adequacy, accuracy, and representativeness. Without these three, we cannot move forward. Without these three items, we cannot make any final decision. If we are analyzing, we are using all these distributions, functions, theorems, formulas. Now, how it works? Accuracy slightly covered a little bit when we said here discussion 7.0, 7.1. We covered, let's say, 0.00001%, right? More or less clear, right? What about adequacy and representativeness? It's very interesting subjects, and I'm going to, again, try to explain now here, try to describe how it works. Actually, what adequacy means? Adequacy means that we want to answer a question. How our model, or is our model, or how our model is close to the real life? That's what we are trying to answer here. Is our model close to the real life, or describes real life? How close? How adequate is our model? And representativeness, to answer question, all aspects are considered. I put here some explanation. We need to understand. Did we take, this is 3, okay? Did we take into consideration all aspects that have an impact on our maintenance, operation, business? As you can, this is practical side. Now next is the theoretical items, mathematical, statistical, formulas, and models. So did we take into consideration all aspects that have an impact on our maintenance, operation, business, math, stats, formulas? Or in other words, do we have enough information, that additional explanation, right, do we have enough information, enough materials to make proper decision? And I'm gonna use here, so this is very interesting example, right? Very important and very interesting to move forward. When I use here, so we have here BPCU, right? Let's say we have something seasonal removal. Again, I'm just trying to put very simple and easy to understand examples, right? Let's say we live this the same the time season, winter, right, or whatever, January, February, winter and spring, January, February, March, but instead of BPCU, as I said, let's use something seasonal. Suppose we have ice detector removals. Okay, just example. So in January, we have 2 removals. In February, we have 2 removals. In March, we have 2 removals. For 9 months, that is remaining, the rest 9 months, we have 0, 0, 0, 0, 0. And our task is, in previous slide, task was to calculate interval, right? In this case, suppose we need to calculate alert level for next year, January. Now, if we blindly take these 12 months removals or informations, not removals, informations, and put in these functions, in the distributions, in formulas, what we see, if we are not doing anything, right? We see that, okay, average removal, 12 months is 6 removals. Agree? Agree. 2 months removals in, again, one removal. So everything is okay. From modeling perspective, we don't have any questions. And more or less, the model is close to the real life, right? We said 2, 2, 2, and 9 zeros. But question now here is this actually represents our real life events and experience? Is this information enough to make proper decision? So what we have to do, actually, we have to go back and check, okay, is this 6 removals? How these 6 removals are distributed? As a matter of fact, what we can see here, actually these 6 removals, they are not distributed within these 12 months. They are concentrated within these 3 months. And then next step, what we have to do, okay, let's check historic data.